Okay. Hi, good morning, everyone. Thank you for joining in. Again, thank to the participant. We are still having people coming in, so we'll wait just one more minute before we get started on this. Okay, let's get started. We are still waiting for our colleague, Dr. Artemis, to join in, but we'll get started here. So again, thank you all for participating in this webinar series. This is hosted by the Bioceramics division within the American Ceramic Society. I'm glad to be one of the hosts here. We'll have our colleague hopefully joining in shortly. We have three great panelists in this session, Professor Paola Palmero, Professor Majid Minary, and Dr. Daniela Carta. And I will start off this event by a very quick flash talk by each one of them, and you'll get to know about them in shortly. And then we'll have follow-up questions from the host, which is me and Dr. Artemis, and then and the audience who are joining in. Again, thanks for taking this time to listen into this conversation. You can please put, as we are going through these questions, please put in your questions in the chat, and we'll pick up questions from there as well. So again, let's get started. So Professor Paula, if you can introduce about your work. Thank you for joining in.
Yes, thank you so much, first of all, for inviting me. It's really a pleasure and an honor to be here. Just ask you if you can see my screen.
Yes. Yeah.
Okay, just try to put it in full screen mode presentation. Okay, so thanks a lot. So I will be short in providing a quick overview about my career. Even if I think that in my case it is important to start from, I can say, from the very beginning. So from my degree, Master of Science degree in Industrial Chemistry at University of Torino. And I would like also to highlight that I carried out a master thesis in a private research center, in a telecommunication research center, when I worked for the first time on materials, because the topic was on a type of glass for optical application. And well, immediately after my degree, my Master of Science degree, I started to work in a private company as a chemist, so as an analytical chemist. I had a permanent position in this company that I left after 2 years to start a PhD at Politecnico of Turin. Okay. And yes, Politecnico is a major institution in the northern Italy that is currently ranked among the best world-leading university. This PhD was the start of my journey into ceramic material, because I started to work on ceramic composite and nanocomposite. And yes, I did my PhD thesis that was co-supervised by INSA of Lyon. After the completion of my PhD, that was in January 2005, I work still at Politecnico as a postdoctoral researcher for around 1 year and a half. Then I became, in April 2006, assistant professor. So this means that still at Politecnico, I had a permanent position as a researcher. I held this position for more than 10 years, where I became, in November 2016, associate professor. And finally, in December 2019, I became a full professor. I just want to underline that this professional career crossed my personal life, because in July 2006, I get married. And in October 2010, I became a mother. During my career, me and my research group, we cover a number of ceramics for functional and for structural application, in particular way for the biomedical application. Just to give some ideas, at the very beginning of my career, I started to work on monolithic ceramics like yttrium aluminium garnet for transparent devices. Then I move quickly to ceramics for biomedical application, starting from structural dense ceramics for orthopedic application and even for dental application. But still in the field of ceramics for biomedical application, we also work a lot on the porous ceramic like scaffold for tissue engineering and in the design and development of functionally graded materials and functionally graded ceramics. Another field of research were ceramics for the environment, including sensor or sensing ceramics for different types of gases and for humidity, and ceramics for CO2 capture. And also traditional ceramics, where the focus there is the sustainability. So we work in finding alternative and green solution to the traditional cementitious binder. And finally, in the very last year, we started to work, I can say, on the same type and classes of ceramic, but using different types of shaping technologies, and in particular way 3D printer, including robocasting and stereolithography. And well, I can finish just saying that this last research field is giving a lot of satisfaction and also a lot of fun. So thanks a lot for listening to this short presentation of career and of focus of research.
Yeah, thank you very much. I mean, there's so many questions on your technical portion, but we'll keep our discussion more broadly on the career path. So thank you for that. Dr. Minary, it's your turn to introduce.
Okay, my screen is good?
Yes.
All right, thank you, organizers, for this opportunity. My name is Majid Minary. I'm a professor in the Department of Mechanical Engineering here at University of Texas in Dallas. And I've been in academia since 2012 after I finished my PhD and postdoc. So because this is a diverse, like, international audience, I'll just make some short introduction. Obviously, we are in the state of Texas, which is the second one in both in terms of area after Alaska and also in terms of population after California. So we are kind of somewhere in North Texas. It's a very large state. And then the metroplex that we are in is called the Dallas-Fort Worth, which is the fourth largest in the US, population of around 8 million. Probably DFW airport is always top 3 to 5 in terms of both number of flights and in terms of size. Interestingly, when I looked it up last time, it's larger than Manhattan and New York. Just the airport by itself is sometimes you land and the taxiing takes more than the flight. But then obviously for people who are into sports, we have the Dallas Cowboys football team in here, which if you look at it, I know a lot of people internationally are into soccer, and now it's World Cup. So we have Real Madrid and Manchester United, that's some of the most valuable sport franchises in the world. But Dallas Cowboy has been always for the last 10 years or so the most valuable sports franchise in the world. So that's also in our in Dallas area. In terms of research, what I do, at least for what is relevant to this audience, we work on 3D printed dental ceramic or zirconia, and we cover different aspects as much as we can do. Look at the strength, fracture toughness, accuracy, trueness, fatigue, hydrothermal stability, translucency, because as we know, our teeth also, they need to be translucent for aesthetic application, and we follow a lot of standards that are made for traditional ways of manufacturing. And obviously zirconia, I know a lot of people work on different type of ceramics for dental applications, but when you talk to dentists and other people, zirconia by far, it's the most used or prescribed restorative material for dental application, or even by 80%. And obviously, there are other ones within 5-10%, glass, ceramic, and so on. So we are very much focused on zirconia. And obviously, this is a long-going debate whether we're going to use whether the traditional way of manufacturing is good, CAD/CAM, milling, or 3D printing. I always say it's not a zero-sum game. It's something that people, their patient, and essentially the dentist would choose what they want, what type of treatment they want, which restoration, whether 3D printed or CAD/CAM. So it's not that one of them going to replace the other one. But traditionally, how the dental restorations are made is usually they either take a large puck of a pre-sintered ceramic in a green state, partially sintered, and they mill them individually one by one with these drill bits. Or if you go to the office, dentist office, they will take a block of zirconia and they mill it. So as you see, at the end of the day, a crown is a shell. So 90% of the material is usually wasted, and also drilling the ceramic creates some micro cracks under surface you may not see. So there are some issues with CAD/CAM. That's why a lot of people are excited about 3D printing that can provide. Obviously, it's not like here you have to do one by one milling. You can make many of them in one shot. In terms of accuracy, is better than the milling and so many other things, advantages that tap, but it has its own problem. 3D printing can be slow, especially the post-processing part, the debinding and sintering. Another point is that the 3D printed zirconia is a FDA approved material in the United States. So it's something that now if somebody brings it to market, essentially is allowed, at least in the United States. What we have been working on specifically is a new process. We call it ultra-fast debinding that allows post-processing. After 3D printing, post-process them less than an hour, so that when the patients go to the dental clinic or the dental office, they can get the restorations within a few hours. And so this process, we rely on a very fast joule heating by graphite felts, and we are trying to commercialize a small scale furnace that is made for this special purpose. And another thing that you need to consider is the accuracy. When you 3D print something, always you look at the original CAD file and the actual scanned sample that came out of the printing after all that long processing, high temperature sintering and so on. And then you need to overlay them. So we use the dental scanners specifically to image the image sample and the CAD file and overlay to see where are the variations, how we can improve them. And then obviously we do traditional things, measure their strength to see if they are good enough for this type of application and so on. So with that, I'll end here, and I'm looking forward to our conversations. I think you are muted.
Yeah. Thank you very much. I mean, it's great to learn about your work. The image that you were showing, it seems like a dinosaur eyes. I'm sure somebody else would have commented on that. So we'll move on to our third speaker. I know Professor Artemis has been trying to connect. It will be great to have a more conversation going on, and she's been trying to connect. But in the meantime, we'll keep going. So Dr. Carta, please.
Thank you. I'm trying to share the screen. Okay, can you see my screen?
Yes, yeah.
Great. So, well, first of all, I would like to thank the organizer for having me on today. So Artemis and Anamika and the American Chemical Society for giving me this opportunity. So I prepared a few slides, not very technical, about my career. So the first slide is a snapshot of my path to academia. So it's a very traditional path, I have to say. So I started with a chemistry degree in Italy, where it's a 5-year program. Then I move on to the chemistry PhD in the UK. I give you a few details later on. And this was a 4-year program. Then I spent a few years, quite a long time, 9 years as a postdoctoral researcher. So here I built all my CV, all my publications. And then I got my first academic position in 2016. And then I climbed the ladder to assistant professor, who I got promoted very, very recently, 3 months ago. So I spent 5 years as a lecturer, then 5 more years as a senior lecturer, and then very recently promoted to assistant professor. So just to give you a bit more details about my journey. So I started my chemistry degree in Sardinia, which is an island in the Mediterranean Sea. As you can see, quite beautiful place to live and work. Very difficult to get distracted, but nevertheless, I did get my chemistry degree in material chemistry. And my final year project was on nanocomposites. So I did synthesize and characterize aerogels of nickel oxide and iron oxide in a silica matrix. So aerogels are very interesting materials, highly porous and with extremely low density. So because I didn't like that much the weather and the beautiful scenery, I did move to England to start my PhD. So I did my PhD in Canterbury, which is a very nice little town near London in Kent. And here I started my journey into the biomaterials. So I did use the same synthesis, sol gel, that I did use for my final year project as my undergraduate degree. But I built actually 4 years project on phosphate-based glasses. There was not much done by that time on bioresorbable phosphate glasses used as biomaterials. So I did start this new topic, let's say, and this is actually the first ever sol gel phosphate glass ever made, and it was a picture that I took during my PhD. Then at the end of my PhD, I did, as I said, embark the journey of postdoc research associate in Italy first. So I went back to Sardinia for a few years, but then back to the UK, where I worked on kind of a challenging project for me because it was a really interdisciplinary one. I was in a microelectronic environment, so I was surrounded by electronic engineering, physics, and engineering, and it was hard for me to obviously work in such an environment. I was there employed as a chemist to work on titanium dioxide thin films for memory stores. And then finally, I started my role in academia, as I said before, as a lecturer and currently as assistant professor in Guildford, which is a town southwest London. So this university is a small to medium-sized university, so you can see the numbers on the slide. So it's quite a friendly environment and a very pleasant university to work, I have to say. And maybe not many people know, but Guildford was also the family town of Turing, which was the father of modern computing. So Turing actually spent a long time in Guildford thinking about the new ideas. So when I started my role in academia, obviously I had to give up a lot of my time, my research time. So I think most of people that do work as a research associate and then they move to academia don't expect that. I was not expecting this because there was no time at all, especially at the beginning, to do any research at all. So I was obviously given lots of different modules to teach things that actually I was not really familiar with, like forensic science, for example. So you have to prepare all the slides, get, familiarized with the content, in order to be able to teach it properly. So I think this is a challenge that many research that start academia face. In addition to this, you also have obviously administrative roles like exam writing, marking, international mobility coordinator in my case. So you're given also admin roles in addition to your teaching as well. So it's quite daunting time for a new lecturer, I have to say. So in terms of research, I started again when I started my role in academia, the research that I did for my PhD. So this is about finding in-solution strategies for making glasses. alternative to the classic melt quenching technique. So melt quenching, obviously, as you all know, glasses are usually made by melting oxides and then cooling them very quickly in order to avoid crystallization. So my work is about finding in-solution strategies. So these are green, not time-consuming, ideally, and water-based. So I use two different techniques. One is a sol gel, which is in solution, but not very green and not very time effective. However, very recently I moved to the co-preservation technique, which is actually all the three things: so green, fast, and water-based. So in terms of the sol gel techniques, we've been working, or I say we because it's myself and my team, working on synthesizes highly porous phosphate-based glasses. So we use phosphate glasses and not silicates because they are bioresorbable, so they solubilize faster than the silicates. So the idea is to have these materials implanted in the body and then to have them dissolved and basically to help the cells grow on them before dissolution. So ideally, these materials have to be porous and therefore they have to be high surface area. They need to form bioactive phase on the surface. So usually we study the hydroxyapatite formation when these glasses are in contact with simulated body fluid. And then we study also the cell growth on them. In terms of co-preservation, we have played a lot with morphologies. So we have prepared them as porous powders, but also as porous fibers using electrospinning. So as you can see, by using electrospinning, we get a sort of cotton-like materials, as you can see in the picture. And very recently, we have also been working on 3D printing these materials using as starting points the gels, so either made via sol gel or co-preservation. In terms of applications, we have studied the controlled release of many different therapeutic ions. This is the example of copper. However, we tried many different things. We have published a lot on, for example, silver, cerium, gallium, and many other different ions. And in terms of applications, we have both explored wound healing. So here you can see some ex vivo studies before and after treatment. And the idea is for this material to help wound closure. And on the right, you can see the in vitro scratch test. So we create a scratch on a monolayer of keratinocytes, and then we study the closure of the wound when our material is added to the monolayer. However, we have also, depending on the composition, obviously, we can tailor the systems because are both in solution. So we can tailor the composition also to have them applied for bone regenerations too. So a really, really versatile system. And I have to say that during this time, my passion is material chemistry. So I'm more on the material side than on the bio side. So I get lots of help from the bioscience department in order to do all the cell work. However, my passion is more on the atomic scale studies. So I was lucky enough to get lots of beam time. So these are some of the synchrotron facilities I've been to. And synchrotrons, I don't know if the audience is familiar with, but they are particle accelerators. So we have electrons traveling at the speed of light under high vacuum within these circles, these rings. And so you can see here on the top left, the UK one, on the top right is the Italian one, and then at the bottom we have two in France. The bottom left is the French one, and the bottom right is the European one that is also in France, in Grenoble. So the beauty of these facilities that at different points within this ring, you can do many different experiments. So my expertise is in XFs, so X-ray absorption spectroscopy and X-ray diffraction. So with these techniques, you can see interatomic distances and coordination numbers in glasses. So obviously glasses are a very difficult system to study because X-ray diffraction, pure X-ray diffraction doesn't give you any information. So we need to get to these very advanced facilities in order to get information on the glass structure. Finally, one of the challenges I encounter when in academia is to find money to do anything because research needs money. So I was, I don't know if you're lucky enough or good enough to get about $1 million during my year after the academic year, let's say. And I also filed 2 IPs as a result of my research. Thank you.
Hey, thank you very much, and congratulations on your new position. We have Dr. Artemis has joined in, so I'll let her say a few words, and before we go on to the next session. So this is our introduction session, and then we have this design Q&A. Dr. Artemis, do you want to? You're muted.
Yeah. Can you hear me?
Yes, we can hear you.
Okay. It has been very complicated to join.
No, we are glad that you could join. So we
Thank you.
had a panelist introduction, and so we are on to our Q&A. If you had a few words to get settled before we start on that.
What I wanted to say is that these kind of meetings are very important to share our experiences, and I'm really glad that we have the 3 guests today, these specific 3 guests, because they have diverse backgrounds, and hopefully we can learn something from their career development.
Okay. So from ours, again, for the people who have joined in, I am Anamika Prasad. I didn't introduce myself. I realized at the beginning. I'm faculty in Florida International University, and I'm also the vice chair of this Bioceramics division. And Professor Artemis, do you want to say about your role within Bioceramics? Yeah.
Yes, I am secretary in the Bioceramics division. And, well, I'm a professor of biomaterials at the University of Birmingham. I didn't say that either.
Sure.
But among all of these problems we had to connect today, we lost our line.
Yeah.
Thank you.
Okay, thanks. So our next set of, is attempt in the next 30 minutes would be 30 minutes or so would be to have this pre-designed question. And Professor Artemis, if you can start with the question for the panelist, and then we'll go over all these 4 questions with each other.
Yes. So our first question is, what really or who inspired you towards a science career? Did you have a role model? Have you been specifically mentored or supported by someone?
So Professor Paola, yeah.
Yes, thank you so much, and also thanks Artemis for inviting me today.
Thank you, Paola.
Yes, so to answer this question, I have to say that I think that I always felt passion for science. This is the reason why I study chemistry at the university. But as I said shortly in the introduction, I think that the experience that I had in the private research center, in the telecommunication research center during my master thesis degree had really an impact to me. It was my first experience in research. It was, of course, short in time and as topics, but I think that I learned what research can be. So for the first time, translating what are the study, the knowledge, the understanding into new ideas, new proposal, into innovation, technology. So it was really, really wonderful for me. And I also think that the environment had then also a big impact to me because I could speak about science, of course, with the supervisor, but even with colleagues. Some of them were chemists like me, some other physicians, some other material scientists. So it was very a nice experience to share what I was doing in such a very nice way. And yes, as I said before, after this experience, I entered a company. So I started to work in a company as an analytical chemist, but I really missed research. And so after 2 years, I did what probably most people think that it was a risky or crazy decision. So I left this permanent position in a good company and I started to work at the university that we know very well that it is characterized for high degree of uncertainty. But anyway, I think that it has been the best decision that I ever made. And well, so probably more than really a modern rule, I think that it was really passion in research. But yes, coming back to the question on supervision and if I have been mentored, I can say yes. I think I have been really lucky since during my PhD and even the years later, my supervisor was a person that also had a role very important to me, not only by the scientific point of view, because she really was a person able to, she really believed in me. He was confident in me and my possibilities. And I think that it has been really important, especially in the most challenges stages, parts of my career. So I think that what I learned is that first of all is to that passion. So you have to follow your passion, even if sometimes it is risky, and also to value mentor and mentorship because it can really make a difference in some difficult situation.
Yes, thank you, Paola. Interesting. I think often I feel we all have a similar backgrounds or similar experiences. Yeah, how we became academics and we developed through the university career. Okay, so is it Daniela?
I don't know. I'm last in order, so maybe Majid comes first.
Majid will go.
Oh,
Yeah.
is it
The same
Majid?
order.
Okay.
Okay,
Yeah.
the same question.
Yeah.
Yeah. So for me, I think the most important, this deciding factor was having an autonomy on what we do, what I do. Like for example, I never thought, if you asked me 10 years ago, that I would ever work on 3D printing of dental, for example, crowns. Had no idea, right? So it's being in academia allows me to really follow things that are interesting to me rather than I haven't worked in industry, but people who have background, this industry can be rewarding, but a lot of times somebody else tells you what to do. There is a big plan and it comes down. And just look at my personality and realize that probably I would not fit in industry, and I want to follow things that makes sound interesting to me. So I think that has been the thing that really attracted me to academia and what we do.
Yes, I agree with you. Yeah, very nice. And it's Daniela.
Yes. So, same question. So, I think I have to say my passion for chemistry started quite early in high school. But when I was in high school, actually, I was not very confident. I'm not really confident even now, but at the time, I was really, really shy. And my chemistry teacher, she was great. She was a woman, and she really wanted to push me to take part of the National Chemistry Olympic Games. And I was terrified. I said, "No, oh my God, I'm never going to make this. To get through this." And I did it because she really pushed me, because she understood that I had the capabilities to do it. And actually, I won the regional competition to participate to the national one in Rome. So I had to do to do the trip at that age, compete with the best chemists of my peers at that age. So it was a great experience. I have to thank her. I will thank her forever because if it was not for her, I would probably never have done this. So that experience actually it was very important for me then to start a chemistry degree. And so I really enjoyed my chemistry degree because the university I was in also quite a small size. So I think it's important. It was a really friendly environment. Even the lecturers were really, really, behaving mostly like friends. We had like one-to-one supervision. It was really friendly environment. So during my final year project, also I had a great supervisor. I was a woman as well, and she had great international connections. So I was put in contact since that early stage of my research career to an international environment. So yeah, I believe the teachers and lecturers are very, very important. They've been very important to me. So I'm trying to do the same with my students. I have to say, try to be a role model as well, not just in academic terms, but transmitting like very strong values such as integrity, curiosity for science, and respect for the others as well, which is as important as the academic role, I believe.
Yeah, thank you, Daniela. That's very useful. Shall we move to the next question? Yeah. Unless if there are do we have questions and answers later on, Anamika?
Yes, after
Yes.
we are done with these, formal questions.
Yeah. Yes. So let's move to the next question. So what were the biggest obstacles you had to? Did you ever perceive the metaphorical glass ceiling, or had to face certain prejudices?
And this question is, the glass ceiling, just to, it's for everybody is a different ceiling. It could be, all kinds of ceilings which can prevent, so.
Yeah. So is it Paola? Yeah.
Yes, thank you. Yes, of course, glass ceilings can be different for everyone. Well, as a first reference, of course, I can make reference to my career as a woman. But I should be honest, I never felt this as an obstacle or really a problem. In particular way, if I make reference to my small environment, I mean my department, since I can say the number of, we can say gender balance is quite good, even in leadership position. Well, if I think to the whole institution, the picture is a little different, because I see that in this case women are less represented, and especially in leadership positions. So for me personally, not really an obstacle. I see anyway there is a room for improving. What I felt probably as my major obstacle or challenge I had to face in my career was probably the balance between my personal life and my career, especially when I became a mother. Well, I have to mention that something that I felt and I feel is the high competition that there is in our career. So I think that our work is a wonderful work, but it is made by many different things. So it is not only research, but it is also teaching. It is also writing project, getting money. Daniela also mentioned all the administrative things that we have to do. And also it is also very important to keep and to grow in terms of visibility inside the community. So I feel that there is a lot of pressure, and especially when I became a mother, when I entered my maternity leave, I felt this pressure probably in a more intense way. And yes, I think that probably this has been the biggest challenge that I had to face. So I had to face, and this also what I also learned is that we need to balance these two aspects. I started there. I still try to do that. So every day I try to balance my personal life with my career. But yes, probably this was and is still the most difficult part of my work. Yes.
Thank you, Paola. I would agree with you. How many times we sleep at 2 and 3 o'clock in the morning to be able to finish our work.
Yeah, absolutely.
I think this is something for me that I haven't resolved. I never resolved, I think. So
yes, it's
I
a
think
continuous search.
theoretically
Also,
we could achieve
balance
some
a little. Yes.
balance. Anyhow, okay. Is it Majid?
Yeah. So what I would say is I always tell people being academia is like 10 jobs in one. A lot of times, people, if you tell somebody I'm a professor, the first question they ask you what you teach. But all of us know teaching is like 5% of our work. Things that people don't know, don't see. You have to write proposal, you have to bring grants, you have to buy equipment for the lab, you have to hire people, interview people, go to conferences, write papers. So, and then a lot of time, these people do not know that the other ones exist. For example, when you teach in a classroom, students really, they think that you are just a teacher, right? They don't know that you have a lab and you write project grants. And then department heads, they want just you to do service. And funding agencies don't know that you really teach and you have a lot of other things. So we respond to so many diverse people that they feel like or they want to think that the other ones do not exist. So it's hard. It's hard, very hard to balance. And as you said, we work long hours. But I think to me, it comes back at the end of the day, just having that autonomy is very important. At the end of the day, we decide what to do, when to do it, rather than somebody tells us, right? So, and we have a choice of sometimes decreasing the amount of things that we do. You say the 1 year you get busy instead of writing five papers, you write one, right? Nothing gonna happen at the end of the day. So it still is your choice. Maybe you're ambitious, you want a lot of things, but you can do that. And then up comes family. I also have three little girls in elementary school age that they take probably at least half of my time. So it is what it is. We have to fit. And as you said, maybe a lot of times working very late at night. It's just the job we have chosen. And when I talk to people, I say if I go back 100 times, I'll still do the same thing that I'm doing now. So there we are.
Yeah, thank you, Majid. So it's our job really demands a large set of skills. Yeah. So
We are never
we have to
told,
be
yeah.
diverse ourselves.
Yeah. While training, we are all focused on like this meeting is also kind of to get that flavor out. Because while we are training, a lot of people who are in the audience, who are in the training stage of their life, the focus as throughout that stage is on getting that technical skill. But as you are developing, growing through that, all of us are here for that passion from the technical skill side of passion. But we also, as we kind of expand our world into different stages, we see the other writing, publishing, talking to people, networking, all those skills bring us to, that's needed, which is a learning process for a lot of us. So, yeah.
Yeah, Anamika. Daniela?
Yes, I just agree on whatever has been just said, because our job is really difficult. I mean, I think the good point that we have more freedom probably with some of the works, for a company. However, we are not rewarded because, our salaries don't take into account any overtime work. When I talk to friends that are working in industry, every single half an hour extra time, they get paid. And we work until, very late at night. However, we have more flexibility, I have to say. So there are pro and cons. And in terms of what Majid was saying about papers, I mean, we have appraisals, unfortunately, and we have targets. So yeah, we need to publish more than one paper, achieve the targets as well. So at the end of the year, there is appraisal that we have to prove and meet the targets that were set the year before. Anyway, so the question was about obstacles. So I think one of the main obstacles I think is getting funds, because that, if you get research funds, then you can get hire postdocs, and then your life become a bit easier because obviously you get help. So the postdoc can help you in the lab, and otherwise everything is much more difficult. And unfortunately, again, writing research grants is not easy because it's not just about the quality of the grant sometimes. Obviously, it depends on the available funds, and especially in the UK, we are really struggling with that because the government and to obviously put money in science and everything is depending on that, so how much money is available, and within a certain call, who else is applying for it? So there are much stronger groups that they might get it because also of the reason, quality, but also because they have more connections. They get, maybe get help writing grants as well, getting more help in the universities. So it's not. I think sometimes if you are in a small university, it's more difficult because you can get less help. In writing on grants. So also, it's hard because you might do your best and still don't get it. So it can be frustrating if you get a rejection. Yeah, so that's very important, and something that is very important to bear in mind also for the audience. You should never be put down by a rejection because that's not always your fault. So you should try again and again and again, and eventually, something good happens, I believe. In terms of the glass ceiling, so this kind of invisible barriers, I have to say, as Paola, personally, I've never experienced that. So I have to say UK is quite a good place to work. So there are very strong, national and university rules and policies in place against any form of discrimination that could be, gender, ethnicity, age, and so on. So I think, my side, I've never experienced this. However, I heard of other colleagues in other parts of Europe that actually do have, and even students in PhD Vivas comments, they're not appropriate at all. So I think it's still an issue in other countries. I'm not saying it's an issue in the UK. I said personally, I've never experienced, and I think if I had, I could have certainly had the tools to complain. The complaints are really taken seriously. So that's an important thing. So yeah, that's my view.
Yeah, thank you, Daniela. Definitely funding is a big obstacle these days, where the budgets are decreased, the competition is huge, and I don't know what the solution is there. Because in the past, I think we were talking about 7% and 10%, that it was quite low, the success rate. Now it's down to 2 and 3%.
Yes, yeah.
At European level as well. So.
Yeah, because obviously European grants are, there's a high budget available, but lots of people apply. So the scale is the same probably. And again, it's maybe the best thing is to join a big, project and do your little part. That could be maybe an option easier probably to have join a big European grant, you do a little bit and get some budget to do that work.
Yeah. Thank you, Daniela. Anamika, we should move, I think, on to the next questions.
Yeah. So we do have audience question, but we'll take it at the end. So for now, we have 2 more questions from the panelists. And we have kind of the next question that we have is we have kind of covered it, but I'll still ask. What has been like throughout, we are aware of the challenges, what drove us to our passion and why we are here. What out of all that you see in your path has been most rewarding, as some of us have kind of attributed to it, but we take the time to, yeah.
Yes, yes, thank you for the question. Well, I think that I had two most rewarding aspects in my career. The first that I would like to mention is when I get the position of associate professor. So I mention this because, as I said in my short introduction, I became assistant professor. I had this position for more than 10 years. In that period, I became a mother, so I also needed to start to understand how to balance in a better way my private life with the career. In that 10 years, some possibilities open, but I lost them. And I felt a little frustrated. I was close a little to lose motivation. So it was, I can say, not that easy period, but I think that I was then able to analyze my situation in a critical way. I had to admit that I was not ready for that position, contrary to some colleagues, even if younger than me. And yes, I decided to continue to work hard, to grow. And finally, this result, this goal that in that moment was important for me, arrived. And yes, so I think that I mentioned this because it was not only a career milestone, but it was a personal satisfaction, a personal victory. When I learned that, yes, probably maybe not the schedule that I had in mind, but maybe determination and perseverance can really help to achieve your goal. The second aspect that I would like to mention that I guess you can understand very well is when I was involved by the European Ceramic Society. In this society, actually, I'm serving as the chair of the Bioceramic division. And it has been really a great recognition for me. So it represented, a trust and recognition from colleagues in Europe and behind. And yes, I think it was also very, very important to me because it allows me to transfer my passion in ceramics to a larger community. It also gave me the opportunity to build collaboration with you, so with the American Ceramic Society, and in particular with the Bioceramic division. And yes, I think that this aspect is really important when we are able to give support to young scientists, to young researchers, maybe to build collaboration, to build position. And so I think that it is really important and give a lot of satisfaction.
Oh, wow. Yeah, it's great to learn. Yeah, as you said, first job itself is a great recognition after going through all that and to survive in that job and, with all the challenges. So thank you for sharing.
Thank you.
Yeah. Dr. Minary, so how about?
Yeah, I think for me, the most rewarding part would be the students who graduate from our labs. So I have had, I don't know, probably 10, 15 PhD students in last 14 years graduate from my lab. And when you see them end up, I have a few students who work for Apple, for SpaceX, for Dell or other companies, large companies. Some of them are professors. To me, at the end of the day, when I talk to people, when I ask what you do, what makes you happy, and so on, it's really, I end up talking about my students, where they are and what they do. And I realize that probably that is the most satisfying part for me, to train the next generation of people and see them become successful and essentially continue the work that we are doing.
Interesting. Yeah.
Yeah, SpaceX, right? So the just went $1 trillion company. So
That's
I
right.
don't know.
That's right. That's right.
Yeah, congratulations. Dr. Carta.
Yes. Oh, actually, I had the same answer than Majid. My student probably did not go to SpaceX, but yeah. So it's very rewarding, seeing a student starting, as a first year PhD and then seeing them graduating, transmitting this passion for research and going with them through the the challenge of a project with them. So that's is really rewarding. So helping students and actually taking them all the way to graduation is incredibly rewarding. But also I have to say the same thing applies to undergraduate because we are very, very small school. So we have like 50 undergraduates in year one. So we really know them. There are no numbers for us. We have one-to-one meetings with them all the time. So we know them as individuals. So we watch them grow into independent thinkers, and they are a completely different persons when they start, when they graduate. As a part of our program, we also have 1 year in industry, and we really see the change when they come back. At the end of the second year, they start a year in industry, and they are completely different people. So they are like our son and daughters, I have to say. We're really, really happy when we see them, thriving in their studies.
Yeah, yeah. So very few profession, in industry, you don't get that. So this particular profession allows you to work and continue working with these group of people. So yeah, thanks for sharing.
Thank
you. So there's more questions on the side asking for your advice, and I will pick up those questions eventually. But I have one more last question before we go to the audience question. So the question is on advice, for people who are coming up, young scientists. If you were to give one piece of advice to somebody who's listening now or in our recording later, what would that be for that? Yeah. Thank you.
Yes, one piece of advice should be to combine passion with hard work. So passion for sure, it comes as a first thing in our career. It's absolutely the first requirement because passion is also drives also creativity and curiosity and fun. So all the ingredients that are really necessary in research. And probably passion is not sufficient, but it is something that it is really related to my personal experience, because when I started my PhD, I had already 2 experiences in industry. One, it was a private research center, and the other one was a company. And so when I entered there, I had, I tried to work probably with a more or less industrial mind. I mean, but I think that a suggestion that I feel to also an advice that I feel to communicate, because being professional, even if you're a student, so meaning meeting the schedules and planning the work and participating to projects with responsibility and commitment, I think that it really helps. And in my personal case, I think that it opened me some door, especially at the beginning of my career. So passion, hard work, as I said before, at the same time, trying always to balance work with personal life and well-being. So this means that sometimes it is also necessary to set some barriers and to really balance things. And yes, I think, and also, yes, the last advice that I could give is also not to lose confidence. So our career is sometimes not linear, but we can call it a sort of roller coaster sometimes, because there are certain moments very hard where projects are rejected, papers are rejected, no position. But also I experienced that suddenly situation can change. And once again, coming back to my personal experience, I think that if you continue to work, to grow, to use passion in research, maybe not with the timeline that you had in mind, but I'm quite confident that position and recognition will arrive. So this is my advice.
Thank you. Yeah. Each rejection hurts you, It's a small paper. It's so hurtful.
Yeah.
But yeah, keeping that
Yes.
passion and hard work. Yeah.
Absolutely.
Professor Minary, how about
Yeah,
you?
so if I want to have one advice, it would be work very close with industry. I feel like nothing is more useless than doing some research for years and years just because you think you can do it or it sounds cool, but nobody cares about, right? And I see it very, very often in young professors who come to academia or other thing. They just learn some skills or they think something is important and they just get into it and do it. And at the end, you realize nobody cares. So I always say before you start a project, you really work on it. At least talk to several people in industry, relevant industry. Say, hey, if I spend my next 3 years on this, me and 2 students, and really solve this problem, would anybody care? And if you hear people are not excited, really don't do it because you're wasting your time and student time. So I feel like in academia, it happens very often. We are in isolation kind of in our thing. We look at our lab, what we have, what equipment we have, what the skills we have, and say, okay, let's do this thing without really getting feedback from outside. So I encourage people, you don't have to get grants from them, you don't have to have funding from them, anything. Just pick up the phone and talk to them or look at industry or meet them in conferences, say, is this something that is important for the society, for people who somebody would care? And then if it's important, I think it will work out somehow. You'll get funding on it, your papers would be published and everything. But if you just do it something just because you like it, it may not work.
I think I agree mostly with you, but some parts of university do not do applied research. So we also need fundamental research.
Yeah, don't take me wrong. I didn't say applied research, but doing fundamental research that's gonna have some application. If you just do fundamental research, just basic fundamental, but there has to be some application out there, right? You are solving a fundamental problem for something applied later on, right? You pick something in industry, they have some big problem, but there is some science that they need to solve, then you do it. I don't say that you do what industry does, but you do science for some application.
Yeah. Yeah, I guess when you have industrial links, you also can solve the problem of funding.
Yes, yes.
So this has advantages.
Yeah, I mean, there are a lot of, opportunities, I'm sure, in other countries, like for at least in US, there's all this focus on in general, also there are pathways like I-Corps and
Right.
yeah, so those are places where students who are working in US can test out their ideas at a very low budget, but they can get to talk. They basically get money to talk to people and see if their ideas are there. So that's a great input to
Exactly.
provide that. Yeah.
Thank you.
Dr. Carter, how about you? What would the advice you would give?
Well, my advice would be to see any unsuccessful attempts not as failure, but a way to get feedback on yourself, because there will be failures eventually. If you are a student, well, at a certain level, everyone has some sort of failure. So if you are, for example, undergraduate, we might not perform on an exam as you might have wished. As a PhD, for example, some of your experiments might not work in the way you were expecting. In every possible stage of your career, you have some sort of failure. But we need to learn from our failures, to get feedback constructively and try to learn from our own mistakes. So don't let anyone put you down or anything put you down. Just to, stand up for yourself and try to work on your own mistakes. That might be my advice. And as Paola was saying, do not forget your well-being, because I can see some of the students carried away, they just don't sleep or they don't do any exercise because they want to really, but that's wrong. You need to find some time for yourself. That's very important. Balance, work-life balance is important for everyone, from undergraduate level to professorship.
I think that's beautiful
Thank
advice,
you,
and I think it
Daniela.
fits with our panel. So is there any other comments before we move to the panel questions from the audience? If we wanted to have any discussion among ourselves based on what we have heard, or yeah. Okay, so I think we are on the third phase of this webinar. We had a chance to learn about all these wonderful panelists and learn about their experience. I think the audience has, so far we have a question. One is I'm going to read out the question for the first question, and Dr. Artemis, you can read out the next one. So the question is, do you think more resources could be made available for staff and students who are
Parents or carers?
yeah, parents or carers. Could we petition for our universities to make this information accessible? And they're interested to know what exists around that line of additional resources in each of the academic institutions that we are representing here. So, and for this question, we don't have to go by turn, whoever is willing to answer this question. So what are the resources that is available? Yeah.
What was the question? I missed it.
Okay. Is there more resource available for staff and students? What are the other resources available in each of the universities for staff and students? And what does that look like, and how is that information available? So
if I must start, is it related to parents or just a generic staff or anyone? I mean,
yeah, I think it would be more relevant to students and staff, because at least in the US universities, parents are not that involved because we are dealing with adults. So it's more about staff and students.
Oh no, I meant like staff as parents, like this. But anyway,
yeah.
Well, I can start. Obviously, I can talk for the UK institution where I work on. So students are really taken care of. They have lots of all sorts of help on campus, well-being, but also academics. So they are really taken care of. Staff as well, maybe not as much, I have to say. However, for example, we have a nursery on campus, which is, it's a private company, but it is basically on campus. So it's very good for parents. Myself, I had a kid when I started my academic position. So that was very handy to have the nursery basically next door. So that's a very good thing that we have here in Surrey. So additional resources, maybe for staff, there could be some more on well-being as well. So we work a lot. There are not many social events going on for staff. There are lots of students, but not much for staff.
Yeah, and I think you have addressed that question, because the question, when I'm reading it again, it's essentially related to staff and students who are parents or caregivers on, yeah.
That's right. Okay, you said that, yeah.
Yeah, thank you.
You're welcome.
Is there any other kind of comments for support?
Yes, I think that we have a similar situation here. I think that with time, our institution increased a lot the support in many things. Yes, for maybe also for campus. So places where students can be hosted for a certain period, especially those coming from foreign countries, and assistance also to find a location and so on. But also, I think that we also increased a lot the support really for students, not only students, for everyone having problem. So this type of mentorship, of support in different fields, even yes, someone to speak and to relate with in case of problems. I think also what I saw during years is that the institution tried to improve a lot these things. So I really hope, I never try myself, but I really hope that the situation is nice, or for sure is better than some years ago.
Dr. Artemis, do you want to take the next question there?
Yeah. So the next question is from probably a student. They say, I have a background in manufacturing engineering, and I did my master's work on biphasic calcium phosphates. I sometimes feel held back by my lack of formal chemistry training as I continue into my PhD. Given your strong chemistry backgrounds and your own career achievements, what are the most important chemical concept or skill I should focus on to bridge this gap and move forward confidently in biomaterials research? It's quite a long question, but I think it's very useful if there is an answer.
I think it relates to people who are working in, like a cross-disciplinary field. Always you feel some of the concept is missing. So we can talk about, how to work in that cross-disciplinary speed. Yeah.
What did you say was the first? It was mechanical engineering or
manufacturing engineering.
Okay. Well, it depends. If I might start, depends. I don't know. I guess the student hasn't taken any chemistry module, I assume. But I think, depends on the type of research as well, because you could try to, work with your supervisor. Is he a master student, you say, right?
The person is moving into PhD.
Okay. Oh, yeah. Okay. So maybe my opinion is maybe talk to your supervisor and try to bridge those gaps, but specifically targeted to your research, because you can't possibly, study all, the field of chemistry. But clearly, you might not need all the knowledge on organic mechanisms. You might want to maybe work more on your inorganic material fundamental. I don't know, maybe crystallography, depends on the specific project. So you can bridge the gap, but certainly you need to liaise with your supervisor and then learn some basics of, materials and characterization. Like you can catch up, I believe.
Anybody else? Paola, maybe?
I fully agree with Daniela. I think that this is probably a common feeling. When you start a PhD, you had a certain background, but I think that most of the time you start to work to a topic that is in some way different from your background. So you need and you feel the need to feel this background. And I fully agree, probably you don't really need to know chemistry perfectly if you have a different background, but probably some basics to feel this background. And maybe you can also try the way to exploit your previous background and put your knowledge and the previous knowledge in this new research. This is something that I always appreciate in my PhD students. So we work a lot on biomaterials. So calcium phosphate is an example. So we work on calcium phosphates. I think that maybe in some cases students had a background in chemistry, but in a different other situation they had a very different background. So we provided them the tools, so literature to fill their gaps. But I also love a lot when they are able to bring their previous knowledge, which is different from mine, and to put their knowledge into what they are doing now. So I think that it's good. You have anyway a background which will be really useful in what you are doing now. But yes, probably you will need just to fill this gap to be just more confident, I think. But I'm quite sure that you have the tools, or you will have easy the tools for really being a successful PhD student.
Yeah, I agree, because also in my case, I have students that didn't have a chemistry background. So, for example, biomedical scientist degrees, the science degrees, this type of degrees, but they were fine. And you learn as you go along. For example, you run a measurement, and then you start, learning about it. What does it mean? And then you go forward and forward. So don't worry, you'll be fine.
Yeah.
Anamika, the other question?
Yeah, so there's one more, and I'm almost coming to a close to this session. So this is from a PhD student. What characteristics or qualities should they have for you to consider them successful? What is your expectation? Like, what would you think they should, how should they be successful?
A good PhD student, essentially, you mean?
Huh?
Essentially, they are asking what is characteristic of a good PhD student, in a way.
Yeah.
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 So if I read the question like there, what expectations do you have for a
Expectation.
PhD student? And what
Yeah.
characteristics or qualities should they have for you to consider them
Yeah.
successful?
You know, a long time ago, I heard someone said this is not just for academia, it's even in industry, anywhere you work. They say people, your boss, if they consider our boss or whatever, they are people usually stressed out. And then the second thing is that they are very short in time. Like typically when we look at ourselves, we have so many things and we don't have enough time. So as I say, if you decrease people level of stress in people and also save them time, you will be promoted or they consider you successful, right? So I think that is the two things I consider for myself when I'm looking at other people who need me or a student. So if I think a student to look at, okay, how can I really help my advisor in terms of time? So if we give them something, I think the expectation is that they get it done. You need to have an attitude of getting things done. I feel like a lot of students come back to you with 10 excuses why this thing would not work, rather than really, instead of thinking about 10 ways that this thing may not work, really see how you can get it done, right? We were not asking you to come back with a lot more disappointing and all that. So I think having this positive attitude, knowing that, okay, I have to solve this problem, not my advisor. If he told me something because he doesn't have time, so I have to, well, not that don't ask question or anything, but know that that is your task. I think having that attitude of problem solving and being a dependent person. So I can look at the students that I have over time. There are some students that you give them something, you are sure it will be done in a week or two, whatever. There are some students that you're sure not going to be done. You ask them next time, did you do it? Oh, I'm looking at it. Did you do it? Oh, let me see. Like, so, that makes a clear distinction because we deal with both of them. And being in this category of a person that get things done, it will always be helpful for students, for anything, for anybody.
Yeah, I hope all my PhD students are also listening because
Yeah.
yeah, this is it's great advice and yeah. So is there
Was it
any
a
other?
So was it a question also for someone seeking a studentship or someone is already enrolled?
Somebody
Because
who's a PhD student, like
okay.
what maybe it could be a person, I don't know exactly, but it could be a person who's thinking of, but they're
Yeah.
asking what are the traits for a successful PhD student? Yeah.
Yeah, well, for me is as well independence. So you need to bring your own ideas. You can't just wait for your supervisor to tell you what to do all the time. Obviously, at the beginning, yes, you need guidance, but then you need your own ideas. You need to read the literature because obviously the supervisor might not have the time as you have to read all the latest publications. So you must do that, and you need to show independence and willingness of bringing your own solutions. So you can't just say, okay, I had this problem, what shall I do? Because you know more probably than me at that time that I had hundreds of other things to do. So definitely, independence and problem solving capabilities for me.
Yeah, thank you,
I
Daniela.
think that I can fully agree with them. Also, in my case, I think that this is very important. I mean, when we start with a new PhD student, typically are the supervisor that propose a topic, but not only propose a topic, but we start to give direction, to give suggestion for research. So we try to also to set experiments and so on. But we believe that this is the basics, so the first level. Then we really would like that the student after studying a lot, because it is really necessary to study and to read a lot of bibliography, they become sufficiently strong to propose themselves, so new ideas, new research lines, maybe also new collaboration, because they saw that there is a wonderful experiments not available in our institution, but we can create collaboration. So really, when they become independent, as Majid and Daniela said, independent, but with a solid background built on studying and reading and really strengthening the culture and the knowledge on a certain topic. Yes, this is also for me.
Yeah, thank you for that advice. So with those questions, I think we are almost close to the time. So I'll pass it on to Dr. Artemis if you have any final comments before we close, or Asa.
I think we heard very nice things today from our three guests, their experiences. Usually with questions, it's everybody's so different. Everybody, people have different supervising style. There are so many other PhD students with different skills, with different interests. I really hope that today we gave some answers to these people who were interested in doing PhD, and I hope they will do a PhD.
Or they're doing great in their PhD. They're just learning from from this great group of people what the career looks like, right? So different stuff.
Yes.
If I might add, PhDs also helps to get a better salary later on, which is at least in the UK is like that. So it's maybe I think some students, at least here, might wonder at the end of their degree, shall I just start a work straight after? Because clearly, in the short term, they will earn more, because a PhD studentship is not, as well paid as a working industry. However, if you do this 3 or 4 years, a bit of sacrifice in terms of, salary or stipend, let's say, I don't know, in the US probably it's higher, I'm not sure. But then later on, you realize that the PhD is important also to get paid more, because otherwise you hit a sort of ceiling that you can't get paid more because you don't have that qualification. So that's also something to bear in mind.
Yeah, absolutely. Thank you, Daniela.
Thank you, you guys organizers, for organizing this one. We all learned something new.
Yes.
Yes, and we thank everybody who attended this webinar today, and you were patient to stay with us until almost 5 o'clock for the UK.
Yeah.
Right.
It's lunchtime here in
Anamika,
US. Yeah, no, and thanks, I would say, the Ceramic Society for giving the opportunity, because we all get to meet and talk about research, but sometimes we have to take a breather like this and talk about so many other things that happens along with research. So that's a great opportunity. Thanks to the panelists for sharing theirs.
Sure, it's a
Thank
pleasure.
you so much for inviting us.
Thank you.
Okay. So,
Bye-bye.
Yeah, with that, I'll close this session
Bye.
again.
Thanks
Thank
again.
you, everyone.
Thank you. Bye.